Okay, welcome to Chapter 5, Lesson 7, Distance on the Coordinate Plane. This is our last lesson for this chapter. Our learning target or objective for this lesson is to find the distance between 2 points on the coordinate plane. We have one vocabulary word for this lesson. It is distance formula. And the distance formula is used to find the distance between 2 points on the coordinate plane. So again, you may pause the video at any time to write down the definition. Slide that right there. Okay, here we have an example. The ordered pair of -2, -2, and 3, 4 are plotted on the graph to the left. Find the distance between the 2 points. Now, once we can do on a coordinate plane also is use our Pythagorean theorem to find the distance. That's one way, and also the distance formula, which we will look at next slide. So we can look at find the points, the distance between -2, and 3, 4 by Pythagorean theorem. Once again, our Pythagorean theorem was a squared plus b squared equals c squared. And if you can remember from last lesson that our legs are a and b, which our legs were given was 5 squared plus given 6 squared of that equals c, or our hypotenuse is c squared. Bump it up a little bit. Okay, so we square 5. 5 times 5 is 25, plus 6 times 6 is 36 equals c squared. We're going to add 25 plus 36 equals 61 equals c squared. We're almost done. Remember, we have to take the square root of 61. So we take the square root of both sides. The squares cancel. This leaves us c. And our square root of 61 is, to the nearest tenth, 7.8. 7.8. So our distance on here would be 7.8 units. Usually use the term units when looking at points on a coordinate plane, so that we can use the Pythagorean theorem on this. Okay, let's take a look at our next slide. And our next slide is our key concept. Key concept shows us the distance formula. Okay, look on the left-hand side, our symbol is the distance between 2 points with the coordinates x1, y1, and x2, y2 is given by the formula. So let's take a look at our chart here. This point right there is 1, 2. And this point right here is given is 6, 6, 6, 6, 6. Okay. Our distance formula is right here. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Once again, some more algebra thrown into geometry. As you see, they took the x1, x2 minus x1. x2 would be 6 is the x2. 6 is the y2. This 1 is the x1. 2 is the y1. And you put them in your formula. Put it over here. Let's try this over here on our own. D equals x2, which is 6, minus x1, which is 1, squared, plus y2, which is 6, minus y1, which is 2, square that. So what we're going to get here now is 6 minus 1 is 5, so we have 5 squared, plus 6 minus 2 is 4, 4 squared. I'm going to pop this up a little bit. 5 squared is 25, plus 4 squared is 16. Remember, that is all under the square root. Now let's add those together. 25 plus 16 is 41. So we're going to take the square root of 41, which is, to the nearest tenth, 6.4. So 6.4 is the distance between those 2 points. So take a look at the distance formula. Obviously, we're going to need to know that. So x squared minus x1 squared plus y2 minus y1 squared, all under the square root symbol. Okay, let's take a look at our next example. Our next example is a real-world example. And what we got going on here is, on the map, each unit represents 20 miles. Each unit is one space. That is 1 unit right there, so that would be 20 miles. The boat is located at 0.48, and the sunken ship is located at -3.7. What is the approximate distance between the boat and the sunken ship? Okay, so our boat is at 4.8, and our sunken ship is at -3.7. We're trying to find the distance in miles between them. First, we're going to take a look at using the Pythagorean theorem. So we're going to draw a triangle here best we can. We're going to go from 3 over here, so we're going to count our leg, which is 1, 2, 3, 5, 6. That's 7 units there. Goes up 1. And then we're going to draw our hypotenuse, RC, right there. So let's do our Pythagorean theorem first. So we have a squared plus b squared equals c squared. So it's going to give us 7 squared plus 1 squared equals c squared. So 7 squared, 7 times 7 is 49, plus 1 squared is 1 equals c squared. This gives us 50 equals c squared. Square both of them, and the square root of 50 is 7.1 equals c. So if we took 7.1, oops, that's a 2. 7.1, I had 20 in my head. 7.1 times 20, which is which each unit represents, because it's 7.1 units away, so 20. So the boat, we are about 142 miles away from the sunken ship using Pythagorean theorem. Now let's try our distance formula. Once again, we write down our formula. Distance equals square root of x2 minus x1 squared plus y2 y1 squared. Okay, let's fill in what we know. X2 is 4. Over here, x1 is -3, so 4 minus a -3. Square that, plus y2 is 8, minus y1, which is 7. Take the square root of that. So here's what we got. All in the square root. 4 minus a -3. The two negatives become a positive. So it's 4 plus 3, which is 7. We have 7 squared plus 8 minus 7 is 1. That leaves 1 squared. So we're going to use that. 7 times 7 is 49. Plus 1 squared is 1. Make sure you do all the stuff underneath the square root sign before you take the square root. Do the square rooting at the very end. So once again, now we have the square root of 50, which we just found out is 7.1. So as you see, using the distance formula or Pythagorean theorem will solve a distance problem on the coordinate plane. Okay, let's take a look at one more example we have. In our last example, using the distance formula, find the distance between 0.5, -4 and y, which is -3, -2, round to the nearest tenth if necessary. So here we have nothing to go off of coordinate plane, so we couldn't really use the Pythagorean theorem. So now here's where we have to use the distance formula. Once again, x2 minus x1 squared plus y2 minus y1 squared. Okay, let's fill in. Got here our first point, our x2. These are x1, y1, x2, y2. If you need to label them, you can. x2 is -3, -5, squared plus y2 is negative 2 minus a minus 4 squared. Okay, let's clean some of this up. Negative 3 minus 5 is a negative 8, so it's negative 8 squared plus negative 2 minus a minus 4. Those two negatives have become a positive, so negative 2 plus 4 is 2. That's 2 squared. So negative 8 squared is going to give us 64, plus 2 times 2 is 4. Okay, let's add those up. Pop the page a little bit. There we go. Add those up. It's get 68. And then the square root is plus or minus 8.2. Sometimes you need to do for the plus or minus because remember, two negatives can make a positive. So negative 8.2 times negative 8.2 would give you 68 approximately. So you do have to account for that sometimes on the plus and minuses. So there you have it. There is the distance formula once again. Any questions, please review the tape or bring those questions into class tomorrow.